Hey everybody, this is Larry. This is day 25th of the Leetcode October Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today's a really special day in my heart. So let's just start with that. I'm in Hong Kong. I haven't done this poem before, so let's take a look to see what's up. Hope everyone's doing alright. Hope everyone's having a good week. It's been really draining here in Hong Kong, but still trying to go and solve this problem. Anyway, today's poem is, I gotta put up more drone videos, but maybe I'll do it in the next couple of days, just of Hong Kong. Hong Kong is beautiful. Yeah. 70th area is 779, cave symbol in grammar. We built a table of n rows, one index starting by running 0 in the first row. Now in every subsequent row, we're going to the previous row and replace each occurrence of 0 with 0, 1, and each occurrence of 1 with 1, 0. Okay. For example, for n is equal to 3, first row 0, okay. Given two integers n and k, return the k symbol in the nth row of a table of n rows. Okay. I guess it doesn't really, if it's the nth row, it doesn't matter how many rows it has, right? But as long as it's n, obviously. All right, let's take a look. So it seems like every row has double the amount of numbers. What does that mean? I want to kind of visualize it a little bit better because there is some, feels like there's some asymmetry here for sure. And actually, instead of doing this, which we can, and kind of doing it manually, one thing that I often like to do, which sometimes I don't do it enough, is to just do it brute force, not necessarily, or knowing that it's not going to solve it, but at least just to give us visualization, right? So let's actually visualize it that way. Yeah. So 0, we replace it with 0, 1, right? Yeah, I skipped printing the first one, that's fine. We know it's 0, right? Oh, oops. We would like to have a desk on these days, but yeah. So okay. And very quickly, you kind of see the symmetry and a little bit of a pattern. I don't know if it definitely is a pattern. I don't know if it's, a pattern that is easy to implement or digest, but the idea seems pretty okay, right? So for every even row, it's going to be asymmetric. In fact, my idea is probably going to be that it's going to divide and conquer, right? So, but actually, I think I'm being a little bit silly because I think we can do a little bit. I can't just look at the pattern just for visualization, but I think now that I think about it, the answer should have been more obvious, which is just recursion, right? And what I mean by that is that you could do it recursively, you can also do it iteratively, but I think recursion makes a little bit more sense. And if you worry about stack size, something like that, n is only up to 30, so it should be okay. Though you can also do this with an explicit stack because it's still recursion anyway, right? So yeah, so let's kind of do it that way, right? So basically, we return get nk, which is kind of a little bit lazy with the naming, but okay, fine. And this is basically the same thing anyway. But okay, if n is equal to 1, then we return 0. It's always a 0. Maybe we can assert that k is equal to 1, right? And do we want to do it this way? And what I mean by that is, do we want to make it 0 index? I like 0 index more. I think I'm just more comfortable about it. I'm an old man set in my ways. I don't know how to do one index thinking. I feel like that's gonna bite me, so I'm just gonna do this, right? Okay, and then now should we just divide and conquer, right? Because we, as we said, I think we said it earlier, which I didn't really pay mind to, is that the nth row will have double the number of things. So that means that, you know, we get n minus 1 and then k divided by 2, right? So c is equal to this, right? That means the previous character, right? So if I mean, we can, I think for, you could probably generalize, or you could write a more slick, like one-liner or something like this, but I'm just gonna write it out because I don't know, I'm lazy, or just like, I don't want to think about it too much to get the first step in, right? So if the last character or the previous character that this current character is based on is 0, then what? Then what is 0, 1? So if k is equal to or k mod oh yeah. So if k mod 2, so yeah, is equal to 0, then we return 0. Else we return 1 because this is 0 and 1, and then else again, if k mod 2 is equal to 0, we return 1, else return 0, right? I think that should be good. Hopefully. Yeah, looks okay here, and well, these are pretty easy examples. So let's take something and try a little bit harder. I don't know. Is that too big? Yeah. Okay, there we go. Relatively confident about this, but I mean, of course, like I said, you can kind of rewrite this in a simpler way. But let's give it a submit real quick, and then I don't know that I think maybe I jumped into this solution very quickly. But the idea here is that given that visualization, basically it is just mapping, right? Because the cave character is mapped to the cave over 2 character, or yeah, k divided by 2 space between, because like we said, every so we don't have to do any math about what the previous row position is. You can even write it like in a different funky way, of just like, was it 0, and then you can write it 0, 1, right? And then you can maybe expand it out a little bit, add more space, and then the 0 would go to again another 0, 1, right? And then the 1 would be 1, 0, and then again 0, 0, 1, 0, wait, 0, 1, sorry, 0, 1, 1, 0, 1, yeah, 1, 0, 0, 1, right? Something like that. So you can kind of see that, you know, if you need this, it just depends on what the previous number is, and dot 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 all the way up. So that's kind of like the way, and you could kind of redraw this as a tree, really, right? I mean, as a perfect binary tree, and once you think about it that way, then maybe that's a better visualization as well. And then you're just going up the tree in that expansion algo. That's all I have for this one. Let me know what you think. Yeah. What is? I mean, I guess the one more thing is, what is the complexity of this, right? So this is actually exponential in a way, or in the way that matters, which is the input size. Remember, n is not the number. I mean, this n is the number, but when you're talking about complexity, it's about the input size, right? And here for k, actually k we are linear, because for every k we divide by 2 every time. So for every bit we do over one operation. But for every bit of n we do 2 to the n for every bit of n we do 2 to the n operation. So, or exponential amount of operation. So this is going to be exponential, or if you want to call it that, like using n is such a weird thing when the n is an input, but it's going to be like 2 to the n plus k or something, right? So it's not, you know, yeah, and that gets, and k is less than n, so oh, is that true? No, 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 that's not true. Sorry. Uh, but yeah, yeah, I think that should be more accurate. Let's say, let me rewrite this out here for a quick second. So let's say n is equal to the number of bits in n, k is equal to the number of bits in k, and remember big K and or capital N, capital K, and small n and small k, then you're going to have all of 2 to the n plus k. And in this case, it's going to be dominated by 2 to the n, just because, not because of the 2 to the n part, because the n and the k offsets, but you can see that k is less than 2 to the n minus 1. And of course, beyond that, it wouldn't really make sense anyway, because that now you're going outside the bounds and stuff. So yeah, that's all I have for today. Let me know what you think. Send me your good wishes. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.